Hello and welcome to Add-on. So today we will be exploring the energy levels that govern how materials conduct electricity. So let's start with a question. What makes a conductor different from an insulator or semiconductor? So to understand this, we will need to talk about the energy bands and the special role this Fermi level plays. So let's first check out the Fermi level in case of intrinsic semiconductor, and then we will check for extrinsic semiconductor. So the Fermi level is a special energy level. In simple terms, it helps us to figure out where the electrons want to be at different temperature. So in case of intrinsic semiconductor or pure semiconductor like silicon without any impurities, the Fermi level is right in the middle of the band. Why in the middle? Because there is an equal probability of finding electrons in the conduction band, that is the higher energy, or in the valence band, which is at lower energy. But what happens in case of extrinsic semiconductor? So, in case of extrinsic semiconductor, there are two cases. So, for N-type semiconductor, we add donor atoms, which add extra electrons. So, here the Fermi level moves closer to the conduction band, making it easier for the electrons to jump to the conduction band to conduct electricity. And what happens in case of P-type semiconductors? In case of P-type semiconductor, we add acceptor atoms that create holes, or what we can call the missing electrons in this structure. So the Fermi level now shifts closer to the valence band because of the extra positive holes. So to recap, intrinsic has Fermi level in the middle, like this. And in case of extrinsic semiconductor, the Fermi level moves up in case of N-type, and the Fermi level moves down towards the valence band in case of P-type. Now let's bring it all together by comparing conductors, semiconductors, and insulators based on their band energy diagrams. So in case of conductors, here the conduction band either overlaps with the valence band or it is partially filled. So this overlap or partial filling means electrons move freely, giving high conductivity. So they are either half-filled conduction band or vacant upper band that overlaps on the utterly filled lower band. Now what happens in case of semiconductors? So in semiconductors, they have a small energy gap, which is even less than 2 electron volts. Now at room temperature, electrons can jump this small gap, allowing moderate conductivity, and the Fermi level sits near the middle for the intrinsic types, and it shifts depending on whether the type is N-type or P-type in case of extrinsic semiconductors. Now what happens in case of insulators? In case of insulators, there is a large energy gap, which is even more than 3 electron volts. So the electrons cannot jump this gap easily. So they show very low conductivity. That's why they are insulators. Think of them as non-conductors in everyday use. Now let's move on to the next difference. And as mentioned earlier, in case of conductors, the valence band is partially filled or overlapping with the conduction band. In case of semiconductor, there is a narrow or partially filled band gap separating the conduction and the valence band. And in case of insulators, huge energy gap between the conduction and the valence band. And the next difference is the effect of temperature. So in semiconductors, the conductivity increases with temperature. Why? Because electrons get extra energy to cross the gap. And for conductors, high temperatures slightly increase conductivity too. But insulators almost show no change with effect of temperature. Now what are the applications? Well, conductors like metals are used in wires. Semiconductors make up electronic devices like diodes, transistors, and are also used in laptop, computer, mobile phones, and many more electronic devices. While insulators are protecting us from current. So remember that it's all about the energy bands and the Fermi levels. Conductors have overlapping bands, semiconductors have small gap, with an adjustable Fermi level, and insulators have very large gap that keeps electrons locked away. Now that we have got the basics, which one of these three materials do you think we use in the electronics most? Think about it. Thank you for watching.